Let's take a look over here on this cylinder right here in yellow. You see that area? We have three areas, and the first area of a cylinder is the front face, which is a circle. Then the second area is the back area, which is another circle, and we have the curved surface here, which is another area. So there are three areas that compose to sum up together to make the surface area of a cylinder. Now, what does a cylinder look like when a steamroller goes over it and flattens it out and turns it from 3D, because cylinders are all three-dimensional, and turns it and converts it into 2D? It actually looks like this. Now, this will help us understand and make sense of how cylinders actually look like flat, but more importantly, how to derive the actual formula for working out the surface area of a cylinder, because anybody can just plunk all the numbers in a formula and come up with an answer. But where did that formula come from? Because if we know where it comes from, we can actually do tricky questions, we can actually excel in our exams and produce better results. So let's take a closer look at this flat 2D image diagram displayed here of a cylinder. So let's have a look here. You'll see there are three areas. There's the area here of a circle, which is the top part, another area of another circle, bottom part, and we have this flat rectangle. Now, this flat rectangle was actually this curved surface around here. Yeah? So when we flatten it out, to find the area of it, all we need to do is find the area of a rectangle, which is length times breadth. Yeah? So it's length times breadth, or length times height. So the area of this particular shape here, being a rectangle, is merely that length times the height. But the question is, the big question is, what is this length from this corner to that corner? Now notice that this corner to that corner wraps itself around that circle. So we need to know the distance around the circle. So what's the distance around a circle? The perimeter, if you like. Isn't it true that's called a circumference? And the circumference of a circle all the way around here is the same distance as all the way to there. Isn't that true? And what is the circumference of a circle? It's 2 pi r. Now if we have 2 pi r across here and height across here, then this area here is merely 2 pi r h, isn't it? So let's write that down. 2 pi r h. That's this area right there. That's the curved surface around here, yeah? So the area of a circle we already know is pi r squared, yeah? And the area of that circle is pi r squared, so there's two of them. So altogether, pi r squared and pi r squared joined together is 2 pi r squared. All we need to do is add those areas together. Area 1, area 2, area 3 added together is the surface area of a cylinder. Now, what would happen if we put on our 3D glasses so we can take a closer look at what this flat object here, the cylinder, looks like in 3D? Because if I put my 3D glasses on, I can see depth and volume. Let's take a closer look at what the cylinder looks like. Here it is right here. It's a different scale, but it's still yellow. We have the surface area on the top of the circle, pi r squared. Surface area at the back here, pi r squared. So altogether that's 2 pi r squared. And then we have this curved surface, yeah? And we already know that's this rectangle. It's 2 pi r h times height. We got it, 2 pi r times height. That's this curved here. So altogether, it's this formula right there. There it is in 3D for you. Now stay tuned. We're about to do some more examples for the surface area of a cylinder.